Okay, let's wrap up chapter 14 and learn about the uses of regression analysis and confidence interval estimates for the slope coefficient. Then we'll talk about potential problems of using regression analysis. So the two common uses for regression analysis are description and prediction. Let's talk about what we mean when we say description first. Description just means that we are primarily interested in analyzing the relationship between the x and the y variables as measured by the regression slope coefficient. To help describe the relationship between the independent and dependent variables, we can develop confidence interval estimate for the regression slope. We learned how to do confidence interval estimates back in chapter 8, so this should look familiar. B1 is the estimate of the regression slope, so that is the point estimate. Then we need to add and subtract the t critical value times the standard error, also known as the standard deviation of the regression slope coefficient. We can use Appendix F for the critical value, but in this video, I will be using Excel. Like before, the degrees of freedom is the sample size minus 2. So let's work through a practice problem. Here is problem 14-33 in the textbook. I'm using the specific numbers from the text, but your numbers in the homework will look slightly different. You can use the Excel file that I provided for this problem and look for the question 33 sheet. It's regarding data collected by Dwight, who's performing an audit of paper products at Dunder Mifflin Paper. The dependent variable y is the time in minutes that Dwight takes to count the reams of paper. Independent variable x is the number of reams on the computer inventory record. There are 3 steps we're going to work through. In A, we're going to create a scatter plot of the data. In B, we're going to determine the regression equation and test if the model is significant using the p-value approach. Then finally in C, we're going to develop a confidence interval estimate to determine if we can conclude if Dwight takes an extra minute to account each additional ream of paper. Here is what your scatterplot should look like for this data. You will highlight the data on the sheet and then go to the Insert toolbar and find the Scatter option under Charts. We have the number of reams on the x-axis and minutes on the y-axis. Looking at this plot, we can see that there is a positive linear relationship, since as the number of reams increases, the number of minutes it takes to count them also increases. For B, we need to run the regression analysis. Here's a screenshot of the regression analysis tool pack. In prior videos, I shared the steps to run the regression analysis, but here I want to focus on one key point. By default, Excel will always include the lower and upper limit of the confidence interval estimate using a 95% confidence level. For this problem, we were told to run the regression using a 0.10 significance level. Therefore, it's important that you input 90% or 1 minus 0.10 for the confidence level. Also, it is important to make sure you include row 1 in your range for the x and y variables and check that labels box so you get the variable names for the coefficients. Okay, now that we have the regression output, let's continue for part B to identify the regression equation and test for significance of the slope estimate. So recall what the hypotheses to test whether regression slope is significant are. First, the null hypothesis is beta sub 1 equals 0, and the alternative hypothesis is that it does not equal to 0. 0 implies that there is no linear relationship or coefficient is not significant. So vice versa, not equal to 0 is there is a linear relationship and it is significant. Here is a snippet of the bottom table of the output from the regression analysis from the prior slide. We first need to identify the beta sub 0 and beta sub 1 in the output to write the regression equation. The intercept for beta sub 0 is 6.258 and beta sub 1, or the slope, is 0.9249. So we can write the regression equation as y equals 6.258 plus 0.9249 times the independent variable x. For every 1 ream counted, the y dependent variable, or the number of minutes, increases by 0.9249 minutes. The problem stated that we should use the p-value approach to test the significance of the slope coefficient. So we can state the decision rule that if the p-value is less than alpha divided by 2, since this is a two-tailed test, then we reject the null hypothesis. We can see the p-value for the slope coefficient rounded to 4 decimals is 0. Therefore, since the p-value of 0 is less than 0.05 or 0.10 divided by 2, we in fact can reject the null hypothesis and conclude that the number of reams is related to the time required for Dwight to count the reams. Let's wrap up this problem and now calculate the 90% confidence interval estimate for the regression slope. Here I've included the full snippet of the bottom table of the regression output. Here is the formula where we take the slope coefficient and add and subtract the t-critical value times the standard error of the slope coefficient. Let's calculate the degrees of freedom first. We take the sample size and subtract 2. So that is 11 minus 2, and we get 9. Next, let's review the regression output and find the slope coefficient, or beta sub 1. We see here it is 0.9249. We go ahead and plug that into the equation. Now we'll use Excel to calculate the t-critical value. We input t.inv.2t and then 0.10 for the alpha and degrees of freedom of 9, and we get 1.8331. We can plug in that for the t-critical value in the equation next. Finally, let's find the standard error of the slope coefficient in the regression output. We see here it's 0.0722. So we go ahead and plug that into the equation here. We plug this into a calculator, and we get a lower limit of 0.7925 and an upper limit of 1.0573. So as you can see in the table below, this matches the lower 90% and upper 90% confidence interval estimates here. This is why it is important to input 90% in the regression tool, and don't make the mistake of referring to the 95% confidence interval estimates unless your problem indicates a 5% level of significance. Okay, so let's interpret the results. Does the 90% confidence interval estimate contain the hypothesized value of 1 minute? Yes, 1 is between 0.7925 and 1.0573. Therefore, you could conclude that Dwight takes an additional minute to count each additional ream of paper. Let's now talk about another use of regression, which is prediction. Prediction is when we are primarily interested in predicting what value the dependent variable, or y, will be when we know a value for the independent x variable. On this page, we have the confidence interval formula, and this helps us predict the average value in the form of an interval estimate. With the prediction interval, this helps us predict a specific instance or an individual value. One way I like to remember this is that the number 1 right here in the formula is because I'm trying to predict one instance. For example, I may want to find the confidence interval for the average salary Miracosta College graduates make after graduation. I'm taking the average for the group, so I would use this formula here. However, if I wanted to predict a single person, I would use the prediction interval instead. Note that Excel gives us the simple linear regression, but not the intervals. So while we can find the confidence intervals through Excel, you would have to use an Excel stat add-in. So we're not going to be working with prediction intervals for that reason, but it's helpful to understand the relationship between the two and what they mean. Let's walk through an example problem using the regression equation to make predictions. So hospital administrators wish to predict the total hospital bill based on knowing the patient's length of stay in the hospital. Data was collected for 138 patients, and the following regression output was produced. Let's identify our coefficients in the problem so we can write our equation. We can see here that the beta sub 1, our intercept, is 527.61, and beta sub 1, or the slope coefficient, is here and is 1352.80. So we can write the equation that y hat for the predicted dependent variable is equal to 527.61 plus 1352.80 times the x independent variable, which is the number of days that a patient stays in the hospital. Slope coefficient is positive, so as the length of stay or the number of days a patient is in the hospital, the total bill would increase by $1,352.80 per day. Let's go ahead and use the regression equation to predict some values. Note that the relevant range for the X variable for the 438 patients that we had from the data was between 1 and 16 days. So using the regression equation, we'll go ahead and use that to predict the average cost for patients who stay 5 days. In 5 days for the X and multiply by 1,352.80 and then add 527.61 and we get $7,291.59. If we were to create the prediction interval for one patient, the interval would be somewhere between $1,545.01 and $13,038.16. So we can see that the prediction interval here is very wide and it's not really useful. So that's why we want to be careful when applying prediction intervals for a particular value. Let's now calculate the prediction for 9 days. We plug in 9 into the equation and we get $12,702.81. Let's wrap this chapter up and talk about some of the common problems using regression analysis. The first issue to be aware of is that the conclusions and inferences made about a regression line are only applicable to the range of data contained in the sample used. So for instance, in the hospital example, we were looking at hospital stays between 1 and 16 days. So we should be cautious about applying our regression model to someone staying at the hospital for 30 days, for instance. Now, we must remember that correlation does not imply causation. And that just because there is a relationship in the data, it does not mean that there's a cause and effect relationship. So one tongue-in-cheek example I share is the correlation between ice cream sales and crime in New York City. Although it is true that the numbers for these two events tend to move in the same direction during the year, that does not mean that ice cream makes people commit more crimes. There can be other factors at play here, such as the weather. More people tend to buy ice cream when it's sunny outside, and that happens to also influence crime in the area since more people are outside. These may be correlated, but there is no causal relationship. Another thing to note is that the R-squared, or the coefficient of determination that we're using to try to explain the variation in the data, only applies to the sample data that we're looking at. All right, everyone, that wraps up this video on some common uses of regression analysis. That also wraps up chapter 14.